Okay, so I put together this slide deck to talk about this really weird thing that was found on Mars by the Curiosity rover on Martian date, mission date, Sol 3556, which occurred on August 2nd, 7th of 2022. This recently made the rounds on Reddit, and anyway, let's get into it. So, this was originally taken by NASA, unsurprisingly, with the Curiosity rover. At the bottom, you can see some animations regarding the Curiosity rover, how it landed, what it looks like, how it rolls around, and how it drills, things like that. At some point during its mission, the Curiosity's drill started to malfunction, and they had to develop a workaround. But anyway, it's probably important for you to just watch that video to see how the rover actually drills. It's not drilling rock core. It's actually just kind of putting like a drill bit into the ground and pulverizing the dirt or the rock, and it analyzes the dust that comes out of that. So anyway, check out these links. They're the original links to the images and to various NASA resources. So getting to the point, can you see my mouse? I hope you can. I'm not a recording person. I don't use the computer like this ever. So this image popped up on a few news feeds, and it's pretty remarkable. So what we're looking at here are some sandstones, and these are sandstone layers that have lots of debris flowing down the hill here. But what has caught everyone's eye is this really strange object here in the bottom corner. And immediately you can tell that it has a really odd shape in comparison to all the other rocks in the image. All the other rocks are, rocky, right? They're just rubble and angular, and it looks like a bunch of debris. But then you look at this thing, and well, it looks like a cylinder. MILTOID on YouTube took this image and colorized it, maybe for the first time, I don't know. But he did a great job of colorizing it, and he explains it really well on how this colorization works and why the colors in this image are reliable, as far as realism goes. So definitely go and check out his video and just see how he does it. But you can see now that it is colorized, the Mars rocks, they're typically orange or red, something like that. And you look around here, and everything is either orange, red, tan, or brown. And then we look at this cylinder, and it's none of those colors. It's gray or green. It definitely stands out compared to the others here. You can kind of get some green hues on the corners of some rocks here. And there are definitely other rocks around that have similar color to this. But in the general vicinity, this is the only one. Maybe you could argue this little guy here. So I went poking around on various resources to try and figure out what the scale of this image was. And ultimately, I don't know what the exact scale is, but using some other images from other studies, I have come to the conclusion that these layers, these laminae in these sandstones, are on the scale of millimeters. And when you have several of them in progression here, this bar represents about a centimeter, maybe more than a centimeter. But this has led me to the conclusion that this cylindrical rock here is approximately 1 to 2 centimeters wide here at its termination. It's really hard to say. I actually think it might be larger than that, but I think at minimum, it's at least 1 centimeter wide. I think someone might be able to find the image and measure it using various resources that I'll point out later. But I don't have the time right now. So this is just a more up close image of this object. And this object, again, as you can see, is quite cylindrical. It appears, at first, people said, oh, it looks like a cone. Yeah, it does look like a cone. But I think that's because it is partially buried here in the sediments. And what's really peculiar about that observation is that not only does it appear to be buried in the sediments, I mean, it appears to be cutting into the layers of sandstone here. Like you see this is this a loose rock or is this a layer of sandstone that it is cutting through? I mean, I would almost bet that it's cutting through this sandstone layer right there. I mean, it's really strange. I mean, this dust, this brown, brownish dust that's covering the rock is very thin. So anything, sticking out of this is either just loose rubble that's sitting on top of hard rock. Like this is rubble, this is rubble. It's sitting on top of hard rock underneath it, right? And there's just this thin layer of dust around it that makes up this darker area. So, this thing it's either a loose rock or it's actually in situ rock. And it looks like this cylinder's cutting through it. Maybe it's not. And this is just a more close version of that. But it's quite pixelated, when it's blown up like this. But, what we need to note here is just how straight the edge of this thing is. And, I've added this little 2D figure here to guide your eye, to shiest you into believing that it's a cylinder. But let's remove that for a moment. So if we look at the edges of this thing, I mean, it's really quite straight. Look how crisp this rounded, this terminal edge is. I mean, that's a circle. And I don't know if my eyes are playing tricks on me, but you can tell that there's this shadow here. And, this image is screen grabbed from MILTOID's YouTube. And he actually darkened this up a little bit. But if you go back and look at the original undarkened image, it almost seems as if you can see the sharp edge of where this rounded termination is buried into the dust here. And you can see where the dust comes up to the edge of the object. And you can almost see it here. And I don't know if my eyes are playing tricks on me, but anyway, it seems like it's there. And you can see some lumps here, but these are pieces of rock that are behind the object. This might be a piece of rock that is in front of the object here. It's really difficult to say without doing better pixel analysis, and it's really not my thing. But also, I think that something important to take away is look at the details of the surrounding rocks. I mean, look at the details around this rock. You can make out some pretty small details here. I mean, like this little pebble. So if there was a feature that was the size of this pebble or whatever this thing is, you would see it on this object, and it's not there. There is nothing there. This thing is totally smooth along its top edge. It's totally smooth along its terminal rounded edge. And even the front of it appears smooth. Maybe that's just a trick of the shadow, but it sure seems pretty smooth. And so, just giving a really rough estimate of how big this thing is, I really do think it's at least a centimeter wide. And if you use the front termination and you compare it to the length of this thing, the length is about 1.5 centimeters long. And so you can see a different image of similar sandstones within the Contigo member of the Mirador Formation, which is where these red sandstones are from and where this object is located. It's located sitting on top of this Mirador Formation. And you can go to this website to see that. Also, I would really recommend checking out the Analyst Notebook, which is a NASA product, I think. And you can go here, you can open up pretty much any mission, any rover, pick out the pictures, and you can actually do measurements on the pictures themselves. Really fascinating stuff. I've learned a lot in the past couple of days looking at this. And again, I just want to point out, you can see some pretty fine details in this image. You can see these individual laminae, so these individual little layers of sand that are, overlaying other layers of sand. And when you look here at the object, there's nothing. And so just to show you This is the Analyst Handbook. I would really recommend going to play with it if you're interested in this kind of thing and you don't already know about it. You can go, you can look for the day that these images were taken. You can find other images like this. This is just one that was taken nearby. I don't know where that cylindrical object is, and I didn't have any luck finding an image with it in it, or even around it that I could tell, that I could measure and give a really direct measurement. But here, hopefully you can see where my mouse cursor is. There's a little pebble. I've measured it in the image because the pixels have a Z dimension to them. And so XYZ, you can the rover knows how far each pixel is from its camera. You can measure distances. And so I measured the width of this pebble here, or this rock, and it came out to be about 7 centimeters wide. And so these are pretty common. I feel like these are the same kind of rubble that you're going to see here in this image. So I really do think that thing is on the scale of at least 1 centimeter wide. And so these are just some of the things that really caught my eye initially. I'd never seen this image before until this popped up onto Reddit. I don't use Reddit, but I do occasionally browse it just because things pop up, and of course I'm avoiding work, and that's just what we do. So MILTOID is the YouTube channel I was mentioning before. Definitely go check out his video. I think this is MILTOID's Reddit account. He posted it here as well, and so you can see all these links and go to them. I want to cover some of the basics about what has gone on Mars, because we want to know what this object is, and the best way to figure out what it is to initially figure out what it isn't. And so a lot of people have suggested, well, there's been all kinds of landers and rovers that have went to Mars. Maybe it could just be trash from one of those, and maybe it could be. There's all kinds of things that we have sent to Mars, and other countries, I don't know, maybe we haven't been told about. Well, yeah, Chinese rover, but who knows? Anyway, Curiosity landed here in this equator region, the southern part of the equator. And the closest thing that in proximity to it is the InSight lander. And this thing doesn't move around. It's not roaming around. It just landed and it's there. It's not going anywhere. Perseverance, this image is old, but it was expected to land in the 18th of February, 2021. I don't know if it actually landed on that date or not, but it's definitely there now. But it's like 2,000 kilometers or 2,000 miles or something. It's really far from Curiosity. And then the Spirit rover's way over here too. So it's really all by itself, and there's nothing out here that it's going to come across naturally unless trash just fell out of orbit and landed by it, or during its descent process, if it jettisoned or lost some pieces, it, in theory could have landed here, but we'll talk about that in a moment. And so where did it land? It went to this place called Mount Sharp, which is in the Gale Crater. This Gale Crater is approximately 3.8 to 3.2 billion years old. You can see the north arrow, so we're kind of looking towards the southeast from here, the oblique angle, an oblique angle of the crater. And I've marked some locations here just because we really need to know what these are and where these little bits of debris could be. And so in this ovoid circle here, the little green dot is where the lander landed initially, or where it was planned to land anyway. That's the approximate location of where Curiosity landed. This red star is where the sky crane crashed. And so if you don't know what the sky crane is, when the lander came down and it descended onto the planet, the sky crane was this like rocket booster attachment that allowed the rover to descend in one piece. And once the rover was securely on the ground, the sky crane went up into the air and flew off to the northwest of the site and ultimately crashed into the ground. And this was all planned out. This is not an accident. This is meant to happen. So this, a little bit more about the geology here. The mountain, I'll just read this. The mountain appears to be an enormous mound of eroded sedimentary layers sitting on the central peak of Gale. It rises 5.5 kilometers above the northern crater floor and 4.5 kilometers above the southern crater floor, higher than the southern crater rim. The sediments may have been laid down over an interval of 2 billion years and may have once completely filled the crater. Some of the lower sediments may have originally been deposited on a lake bed, while observations of possibly cross-bedded strata in the upper mound suggest aeolian processes. Aeolian processes are just wind-blown geological processes. However, this issue is debated. Of course it is. And the origin of the lower layers remain unclear. Of course it does, because we haven't been there, and it's really freaking hard to figure out how this stuff works just by sending a little probe. If katabatic wind deposition played the predominant role in the emplacement of the sediments, as suggested by reported 3-degree radial slopes of the mound's layers, erosion would have come into play largely to place an upper limit on the mound's growth. So effectively, this was thought to be a lake. So you have the crater form, something hit the ground, I guess a meteor hit the ground. I don't actually know how the crater formed. But now it's just a big hole in the ground. And back, 3.8 to 3.2 billion years ago, Mars was apparently wet. And so when you have a low point, it's going to gather water. And sometimes a Loch Ness monster will grow in that water. And so over time, at least initially, these little streams, just like here on Earth, they're carrying sediments down into the crater, and it's forming a base layer of sediments. And then as the climate on Mars got drier and drier, this water evaporated and became more and more shallow. You're building up sediments on the base of this crater, and you're also evaporating water. And then it went through some processes that were purely wind-blown sedimentation. So wind is blowing sediment into the crater. And then occasionally water will come during, rain events, water events, whatever goes on Mars. So you have a mixture of things. Initially, it was primarily water-dominated sediment deposition, and this transitioned into wind-dominated sediment deposition, and ultimately wind-dominated erosion. And so here is a figure from Vasavada from 2022. This is just an overview of the Curiosity mission, talking about the geology that they've learned. You can see here at Bradbury Landing where the rover initially landed, and you can see its pathway over several years, over 10 years to get to this point, which is where the image was taken. So it landed in 2012. Image was taken 2022. And its current location is way up here in the hills. It's made a big trek. It's really impressive. I don't really keep up with NASA stuff, but this has been an incredibly impressive thing to read about, and highly recommend you do the same. This is just another image of that same or similar viewpoint. So we're looking towards the hills, kind of towards the southwest again. The colors here just show mineral domains. And what I mean by that is the green colored rocks are clay bearing versus the yellow colored rocks are sulfate bearing. So these are just domains. There's nothing, these aren't like geologically separated. These aren't like time bound domains. They're really relative to one another, just kind of based on their mineralogy. This is the view of Mount Sharp from the Curiosity from September 9th of 2015. It honestly looks like, I don't know, somewhere in the desert here in the Earth. It's kind of uncanny to look at this. I mean, if someone showed this to me, I wouldn't know that it was Mars. It's really cool. And so Mars ultimately went up. It's looking east into the hills, and it's gone up into these hills. I don't know exactly where it is based on this image, but I do think it's here somewhere right now today. So using the Aeolis notebook, I was able to, someone plotted the traverse of the rover, and you can see every day that it spent on its journey across this path, and it's made a lot of progress. It's covered a lot of distance. And so you can see its starting point here towards the north. I think this image is, I don't know if it's oriented north or not, but you can see it. Yeah, it is, I think. So you can see where it started here towards the north. It went towards the southwest for quite some time, and then it turned towards the south, and then it started heading southeast up the hills. So this is down in the valley where it began, and now it's been cruising up this hill slowly. And you can see this pink star is where that image of that cylinder was taken. You can see these are just, nice hills. I would love to do geology out here. Closer look at where that image was taken. So you can see the different days of the mission. So 3563. I'm not sure what this 97 is. So 3556. This is right here is where the image was taken in this general vicinity. So this thing is here. There it is again. So this is a really good geological overview of the mountain. And this is a paper by Meyer et al. Published in 2025, so it's pretty up to date. I tried to find the best, most up to date geological profile I could. And they've just been adding to it over the years. I actually found like 3 or 4 of these, and I kept changing this because I kept finding a more up to date one, which is great. And so really what I wanted to point out here is, don't worry about most of these images, but what I want to point your eye to is panel C, which shows the pathway of the rover, in particular this pink line. And this pink line denotes the Mirador Formation. So the pink line is where the image was taken. So we're in the Mirador Formation. So the Mirador Formation is made up of the Dunedin, Port Logan, and Contigo members. And the lithology of these things is sandstone. So this shows that the thing is, pretty much just sandstone. I think it may have mud layers in it too, but they're not much. But you have a lot of cross-bedded sandstones, and these are interpreted various ways to be, I think, aeolian or wind-blown sand dunes. Primarily, but you do get some kind of cross-cutting lenses of cross-bedded sands that are indicative of water flow. So you have wind-blown sand dunes, and you occasionally have some kind of precipitation event or some kind of flooding event, but primarily it's dry with the occasional bout of water. So the Sol Curiosity on a Sol 3556, Curiosity was in the Mirador Formation. This formation is less than 2.1 billion years old, based on the age dating of the Murray Formation, which is down here at the bottom. So, if you're not familiar with geology, in this case, these sediments are all basically undeformed, so they've just been piling on top of each other year over year, and so the sediments at the very top are the youngest, and the sediments at the very bottom are the oldest. And so the bottom of this Murray Formation is 2.1 billion years old, give or take 0.4 billion years. So anything above that is younger than 2.1 billion years old. And they don't know how old it is, I don't think. Maybe they do. I couldn't find any information on that, and maybe it's out there, and I just didn't have time to find it. But yeah, anyway, the important takeaway here is that the location of the Mirador Formation is sandstones. It's primarily sandstones. And if you read the papers here, these are cross-satisfied sandstones with some clay and mud layers. Sand grains are the largest particles here. So think about going to the beach, getting sand in your shoes. That's the biggest particle you're going to find there. And the smallest particle, be clay. This is an older stratigraphic column, but effectively showing the same thing. What I wanted to point out is at the bottom of the column is this conglomerate. And in this conglomerate, you can get pebbles. And so, this object in question, could it be a pebble? Could it be a cobble? Could it just be some really weird large rock? Well, if it is, it's not from this formation. And I'm going to tell you why. The easy answer is because it's at the bottom of the hill, and rocks don't roll uphill. So this is a picture of pebbles. If you live in a basement and you've never left before, these are rounded rocks that are rounded by the force of water, either from waves at a beach or through river processes. So rocks just tumble over each other and they break off all the sharp corners, and they most often trend towards rounding out to spheres. They do, however, round out towards these plate type shapes, and that just has to do with the fabric of the rock. So some rocks literally are still quite layered, and so when you break off a rock in layers, it's kind of like I don't know, peeling pancakes off of a steak of pancakes. It doesn't get round, it gets flatter, you know. But the sides round off. Everything is rounded here. There's nothing angular. You see this rock here, that rock has been broken. So it has a pretty like sharp face, you know, that does happen. So anyway, but the vast majority of these are round. And if our object was one of these rocks, where are the others? So the Martian fluvial conglomerates at Gale Crater, observations by the Mars Science Laboratory mass camera, the MASSCAM, and the Gale Crater revealed isolated outcrops of cemented pebbles. So these are already like isolated. They're not even that common. These pebbles are 2 to 40 millimeters in diameter. And so if my scale is correct and that object is at least 1 millimeter or 1 centimeter wide, it doesn't fit anyway. So even if these pebbles did happen to get crawl uphill and get deposited there, just the one, it's not the correct size. Anyway, feel free to read this. And these pebbles are primarily feldspathic in composition. They shouldn't be dark, and our rock is a dark color. And this is just more image of pebbles. This is what a conglomerate looks like. I guess most people probably haven't seen this. So, you know, you get what effectively is a sandstone or something loaded with pebbles, and it all compacts, turns into a hard rock. Like you have like a sandy beach or something, or a river bank that's a lot of sand but lots of pebbles too. It all gets compacted into a conglomerate sandstone, and they're very beautiful rocks actually. And this is just a cartoon of what this looks like. So here at the bottom, we'll find our pebbles, and this is where the rover landed initially, and I think it saw this on the valley floor, and the presumption is that it's buried under all this mudstone. So this is what the cartoon is, you know, assuming it's down there somewhere. But our little rover is not here. It has crawled up the mountain into the upper Mount Sharp area. No pebbles. So I posted on MILTOID's YouTube channel, and basically I said, I'm a geologist. And I've been looking at this for an hour. I can tell you with absolute certainty that this is not a geological object. What did I say exactly? So when Miltoy posted this on YouTube, and I actually watched this video, I made this comment, and I said, I'm a geologist, and I've been looking at this image for the past hour, and I can tell you with absolute certainty that geological formations, at least the ones we know of, do not have cylindrical features as crisp as this. And what I meant by that was there's no geological process that is going to form a perfect cylinder. It's not going to happen. It doesn't exist. There are no perfect objects out there that form naturally, to my knowledge. They may look perfect, you know, initially, but when you actually inspect them, they're usually not. And maybe this object that we're looking at is really not perfect, and the image resolution is just not good enough to tell that. But it really does look like a straight up cylinder, like a pipe or something. Anyway, I made this comment, and it really got some Redditors butt hurt. So we'll talk about that in a little bit. What it looked like to me initially was that it was drill core. And I think one of the suggestions was like, oh, well, the rover maybe drilled it and then it ejected the core when it was done with it. And it turns out this rover doesn't do that. It can't drill core. The Perseverance rover is 2,000 miles away. You know, I don't know if it's trash. You know, it's a miracle that it came across this trash. Maybe not. I don't know. We find trash all over the planet now, so God knows it's all over Mars and the moon at this point. But I just find it really peculiar. It looks like it's embedded in the hillside. It looks like it's perpendicular to the slope of the hillside. It's just really strange. And some people keep saying that this is the Sky Crane lander crash debris. Well, it's not, and I'm going to show you why. And so this is basically the response I got from a handful of Redditors. Just calm down, guys. First one, Chocolate Chingus, if that is your real name. I don't think that guy's a real geologist. He sounds like he's talking out of his ass. It's impossible to positively identify that as not Sky Crane debris. Okay, guy. Well, I'm going to. So here's an image from the actual Sky Crane debris crash. And so when it crashed, I think this is like some kind of chemical image. So it's showing the chemistry of the minerals down there on the surface. And you can go to this website and read it for yourself. But basically, the rover landed down here in the corner, like beyond the image or beyond the edge of this image, and then the rover or the Sky Crane flew off into the distance to the northwest, crashed, and all the debris scattered towards the northwest, away from the rover. And so on Sol 3556, which is where this image was taken, which is where our cylinder is, the rover is way up in the mountains. Like, it's up in the hills. And it's 10 kilometers away from where Sky Crane crashed. It's 580 meters above the Sky Crane crash site. So, like, dude, it's not the Sky Crane crash. Get over it. Here's some other comments. Wait until this so-called geologist sees the Giant's Causeway in Ireland. Those hexagons must be aliens. He'd probably say the same thing about the perfectly hexagonal granite shafts all over the U.S. Well, first off, they're not granite, they're basalt. Or the smoothly near-spherical stones in every river and creek. Any geologist should know these formations. The bigger issue is that any self-respecting scientist can make any conclusions with absolute certainty based on a cropped, blurry image. The only rational conclusion we can make from looking at this image is that the formation is interesting and deserves more study. Okay, guys, well, for one, this isn't hexagonal, so why are you even bringing that up? And two, it's not spherical. It's a friggin' cylinder. It's not a ball. Like, are you blind? And, this guy, absolute certainty. Like, dude, I'm not saying what it is. I'm saying what it isn't. And it's not geological. And I'm open to the idea that it is. I'm open to the idea that I'm wrong. Like, prove me wrong. But it just doesn't fit, man. It doesn't look like any of the rocks around it. It doesn't have the same shape. It's not even the same color. It's not even, like, a consistent size with the other rocks. So let's all just calm down for a moment. So this is what they're talking about, the Giant's Causeway. I don't actually know where I got, where these photos are from. I just grabbed them really quick from Google. But, they're like, oh, perfect hexagons. Look at this image in the bottom. None of these are perfect. Like, some of these aren't even hexagons. This is a pentagon. There's hexagons, there's pentagons, there's septagons, there's quadragons. I don't... Four-sided, they're coming all sides. Like, the six-sided thing is just an ideal shape that happens more often than not, but they're not perfect. I mean, look at it. None of these look perfect to me. And they're really big, like, for another thing. Like, look how big they are compared to this guy. Like, what we're seeing in our image is 1 to 2 centimeters across, and these are, like, I don't know, a foot wide. They're huge. And here's our little guy here. Like, do these look the same at all? And look how many there are. There's like hundreds of them in this image. All side by side by side. And this is all alone. So you know what? Like, what's wrong with these people? This is how a really cartoonish way that these hexagons form. You have a basalt lava flow. Think of like a pool of lava. And as it cools, the minerals crystallize and the volume contracts. And so, like when your water freezes, water expands. And that's why ice floats. It's less dense than the water below it. But most minerals don't do that. They tend to contract. And they will sink, if they had an equivalent of water to sink in. So when they contract, the hexagon shape is just the most ideal shape for contraction because it's going to break apart in these little columns. and it will cool from the surface down. So like the lower part is still hot, and it gets cold wind or water on top or whatever. It gets colder and it breaks apart. So these are not perfect hexagons. For one, they're not necessarily hexagons at all. For two, and then for three, they're really big, they're really numerous, and they're volcanically derived. And we're not in a volcanic environment. We're in a sedimentary environment surrounded by sandstones and clays and mudstones. There's nothing here that is akin to basalt or granite or anything like that. Our object is cylindrical. Cylinders are not hexagons. Good job, guys. And so, just to touch on this cylindrical shape again, how do you get the cylinder from nature? I don't know. I don't know how you get a perfect cylinder from nature. I'm not saying the object is a perfect cylinder. I'm saying it looks like a perfect cylinder. And maybe it isn't. Maybe it's all a trick of the light, but sure looks like it. So anyway, in nature, when you have a rock and it's rolling around, or it's getting blown around, or it's getting transported by water, or it's bouncing along the riverbed, it's going to knock off the sharp edges. They're all going to break off. And, this doesn't take a genius to know this. Just think about it. Take a cube of ice and throw it around for a while and see what you get at the end. Are you going to get a cylinder? No. You're going to get a blob of like misshapen stuff, and it's not going to have perfect edges probably. You can get some pretty perfect edges out there when you cleave rocks, but that's the only one we saw. So I don't know. So anyway, there's this concept of sphericity, which means how spherical is it, and there's a concept of angularity, which is how angular is it and how rounded is it. And so obviously more rounded means it's more round, and high sphericity means it's more of a sphere. If it's low sphericity, it could be something like a cigar shape, or like a potato, or something elongate, like a plate. And it doesn't necessarily have to be rounded. It could be angular. And these things, of course, do exist in nature, and they're not uncommon whatsoever. So I went through Google and I started looking for cylindrical objects, cylindrical natural objects. And, you can skip ahead, but basically I found none. So starting off, cylindrical ironstone concretions was the first thing I looked for, because you do get concretions in sandstones and mudstones and things like that all the time. And I've seen these. I'm sure you've seen them too if you go outside at all and look at rocks. They're usually pretty bubbly. They're kind of round. They're bulbous, somewhat irregular. But you know what they're not? They're not cylinders. They're not cylinders. They look nothing like this. Look at these images. Next, I just searched for cylindrical rock. And you know what I found? I found a bunch of cylindrical drill core that was made by human beings. Drill core, drill core, drill core. That's not a drill core. This is a carbon rod. Drill core, drill core, drill core. I don't know what this is. Drill core, drill core, drill core. All these things that look like cylinders have been machined by human hands, with the exception of this little fossil down here at the bottom, which is not a cylinder. It's more of a cone. This is all drill core. Nothing natural here. And then I found these things, which at first I was like, ah, damn it, they got me. But no, these are carbon rods from batteries, apparently. I mean, I don't know, maybe they're not, but everyone seems to agree that these are carbon rods from batteries. So any old battery that you have in your house has a carbon rod in it, maybe, unless it's a lithium ion battery. But if you throw this thing in the river, eventually the battery is going to tear apart, and what you're going to have left is carbon rod, and it's going to roll around just like any other rock, and it's going to get rounded out. And if it goes to a beach or something, people will find this, just like beach glass. I mean, if you've seen beach glass, it's the same concept. If you break a bottle, it's really sharp, it'll cut you. If you throw it in the ocean, eventually it'll roll around in the sand and it'll get smoothed out, and it'll turn into something that looks like this. And then on the right, these guys found these rocks, and everyone seemed to agree that these were actually drill core that had been rolling around in the river for some time and had gotten smoothed out. Maybe not. Maybe they're natural and no one has found their geological formation yet. But I'll hold my breath. These are more of these carbon rods. And then here's a thermometer tube that has been rolling around on a beach somewhere in the UK. I can't remember where this poster's from. But they found a ton of these, and apparently, like, it's really common to find these things, especially if there's a trash dump nearby, which is sad. But they are pretty cool, I guess, to look at. Anyway, we've got a cartoon of our cylinder and this actual object in question. These are these carbon rods. You can buy them. Anyone can buy them. They're in household items. You probably have some in your house right now in your batteries. Not natural. Oh yeah, Master Roshi. Bingo. The absolute certainty shit lets me know that's not a real geologist, let alone a scientist. What is it with Redditors saying bingo? No one says bingo in the real world since, I don't know, the 80s, 90s? Bingo. Stop saying that. Natural processes do not create perfect cylinders. They don't. There's nothing geologically happening within the Mirador Formation that would create a cylindrical object. There isn't. It is sand. It is mud. It is a low energy environment. It is not creating cylinders. If this is a natural object, a natural geological object that happens to be in the shape of the cylinder, it did not come from this location, and it shouldn't be here. There's no explanation for why it's here. And it's really peculiar. Stop saying bingo. Oh, and then purple hex. 2 degrees in geology. Doesn't use them, though. Although I refuse to call myself a geologist since I do not work in the field, your boy here is talking grade A shit. Well, there is no end to the number of fossils or geomorphological features that can be cylindrical in shape. Okay, purple hex. I get general cylindrical shapes do occur in nature. That's not what I said. I said, do not have cylindrical features as crisp as this. As crisp as this. It's a perfect cylinder, dude. Maybe you need glasses. Read my comment. Fossils. The remains or impression of a prehistoric organism preserved in petrified form or as a mold or cast in rock. So, a fossil is not like geologic in nature. It occurs within geological formations and it may be preserved due to geological processes. But a fossil, the imprint or the remains are biological by nature. And so, if Purple Hex here is saying we got fossils on Mars. Awesome, dude. It's the only one of its kind. Found alone here on the side of a Martian mountain. No other examples on the Martian surface. Ignored by the Curiosity rover crew. So let's look through some fossils and see which ones are. Let's look at this endless list of cylindrical fossils. So, just Google cylindrical fossils. And it's going to show you a whole bunch of round fossils. And some are generally cylindrical in shape. This is a drill core. That one got me really excited when I saw that one pop up. I was like, holy crap, what fossil is this? It matches ours perfectly. And then you click it, and it's a freaking drill core. It's a drill core. A lot of crinoids pop up. You can see the ridges on these things. I mean, look at the ridge on this. This is a nautiloid. I don't know my fossils. But, I mean, look at all these. They're all highly textured. This is probably a drill core too or something. That's like a piece of coral or something. Nothing in here matches what we see. And really the closest thing, I mean, this nautiloid here is it, and that's not far off really, but like it doesn't have the sharp end. It's tapered. We don't know if this is tapered. It's covered up. But you see the ridges here. There's no ridges. You see the tapering of the belemnites. There's no tapering of the belemnite. And the belemnites, the ones that I have a whole box full of them. Like their ends are all broken and jagged. But again, like, do you think this is a belemnite? Because if it is, you need to call NASA, and let them know. Yeah, and record your call with them because I think we'd all like to hear it. This is more pictures of belemnites, and this is not fair because this is polished here and they have doubly pointed ends, and I maybe they really occur that way in nature. I don't actually know. I've never seen them not broken. Um, but this is the way I always see them, like one pointy end and one broken end, and this looks like an ammonite. Um, yeah, so like that's not really a cylinder, that's a cone. These are cones. If you were to break it off, if you were to break the tip off and just have like a perfect shear face, yeah, you could get that. But again, like you're suggesting that this is a fossil on Mars, the only one of its kind, in the only spot that it's ever been found. There's these other things called scolithos, I guess, burrows. You can make these like inverse fossils, which are just kind of like vacant spaces left behind. So these are burrows, and I mean, there are other cylindrical fossils out there, but there's not anything like this. Not with a sheer round face, circular face on one end, and then no features and the straight edge. This is a cylinder. I mean, it is. It's who knows what's under this dirt here, or if maybe it's just a sheared off. Maybe there's nothing there, and it's like this perfectly flat cone that just molded to the hillside. But there's nothing, and I challenge you to find something that matches it, to find it, and then to put it up on the image and compare them and show us how they fit together, because nothing in any of these images fit together, with the exception, perhaps, of the belemnites. This is not Martian bamboo. This is, I think, some kind of prehistoric tree or bamboo from China. I don't know. I don't know where I found this, but it was a remarkable image, and I wanted to include it. It is actually quite cylindrical. I mean, look at it, but it has all this texture, and it's broken, and it has segments, and it has all these features that aren't here, right? And this actually looks quite large. I don't know what the size of it is, but you can get plants, fossilized plants, trees, tree trunks, but they're all going to have these texture. They're all going to have texture to them. There's no smooth tree out there. Well, I take that back. There's some smooth trees, I guess. But anyway, hey, you think this is a tree? Call NASA, please. Call it, record it, tell us what they have to say about that. So, I never thought we'd run out of the endlessly crisp cylindrical fossils in the geomorphologies, but, Purple Hex identified the first perfectly cylindrical fossil ever, and it's on Mars. So it looks like your 2 degrees were useful after all, Purple Hex. I'm proud of you, buddy. So, here we are. Is it landed debris? No, it's not. And you can go back and see why. It is 10 kilometers away. It's half a kilometer in the air. The landed debris went in the other direction. It is not landed debris. It could be trash. It could be trash from other stuff that has went to Mars. It could be trash, from the greater descent to the surface. I don't know. I don't know what this thing is, but it could be anything. What I'm saying is that it's not geological in the sense that it does not fit with the local geology whatsoever. It doesn't look like these rocks. It doesn't look like any other rocks and any other image of the immediate area or of the entirety of the Curiosity mission or missions. There's nothing like this. This is the only thing that we've seen that looks like a cylinder. And so if it is geological, it is like a one of a kind thing. And maybe it's not from here. Maybe, I don't know, man. It just doesn't fit, and I'm saying that it's not geological, and until someone proves me otherwise, that's what I'm going to believe. Yeah, different shape, different orientation, different color, all alone, only color shape like that. It's just, highly geometric in its shape. It's featureless aside from its geometric shape. Could be a rock, but it's super precise, and it's unnatural in this environment. Is it a fossil? Hey, man, I'm so open to the idea that it's a fossil, but it would be the first and it would be the only one ever found. Could be a belemnite. And, if you're really convinced that it's a fossil, y'all, go ahead. Call NASA. Record it. We all want to hear it. So in conclusion, whatever this thing is, it's out of place. Maybe it just happens to be the smoothest, roundest, most cylinderiest rock on Mars. And Curiosity found it. Maybe it really is a fossil, and the Curiosity crew missed the chance of a lifetime. Or maybe it's just something else entirely.